Good afternoon, everybody. Welcome to our Sunday Space Show program. Thank you very much for tuning in. And I'm going to skip all the front end um, announcements and work, and I will pick them up at the very end of the program because we have an hour with Dr. Avi Loeb, and we want to spend as much time with him as possible. I'm sure he doesn't need an introduction, and he has been on the space show several times before, but he is an astrophysics professor at Harvard. And Avi, welcome back to the space show. Thank you for being here.
Thanks for having me. It's a great pleasure and privilege.
What I want to start out with is in case we're reaching some people who may not know anything about 3I, 3AI Atlas, what it is, and I'd also like to know why it's controversial. And I'd also really like to understand how you see things that traditional scientists, astronomers, and others don't see. I have found this to be really important in medicine because I have a kid with a genetic illness, and doctors that see things that others don't have made a huge amount of progress in treating cystic fibrosis over the years. And I'd like to know a little bit more from your perspective of what makes 3AI Atlas so unique and why we got such lousy, blurry pictures from the NASA press conference. I can't determine anything, but I'm not a pro. But
Mhm.
but they're really horrible pictures from my perspective. I don't know what you or other scientists could have gotten from them. What do you think of all this?
Let me start with the end remarks that you made about the NASA press conference. The images are blurry because the cameras that were used to take these images were not optimized for the purpose they were used. They were, for example, the high-rise camera on board the Mars Reconnaissance Orbiter was designed to look at the surface of Mars. Okay, so the entire analysis system was designed for that. And when you have an object moving in the sky, like 3I Atlas was at about 67 kilometers per second relative to the sun, you know, that they had the difficulties tracking it without some jitter in the camera and so forth. And that ended up uh, degrading the quality of the image. And moreover, I actually looked into the data in great detail yesterday, and there is not much information in it. So my conclusion is that they made two mistakes. The first mistake was to address the public and say there is nothing really particularly unusual about this object, basically lowering expectations and saying there is nothing mysterious. And as I'll describe in a few minutes, I'll tell you why there are lots of things that are quite mysterious about this object. But when you approach the public, you want to excite interest. You want to explain why you are investing time, resources, and why this particular object is worthy of a press conference. That's the fundamentals when you approach the public. Now, they didn't do that. And the second mistake is, given that the data was not very impressive, don't hold a press conference. You held the data for 45 days during the government shutdown. That's fine. You know, that's bureaucracy ruling over or sabotaging science. That's fine. That happens in many organizations, including universities, where bureaucracy dominates the scene. And we all know about that, and we all think that it's inappropriate because bureaucrats are supposed to serve scientists, not the other way around. But nevertheless, we understand that NASA is a big organization and they had to shut down any operation during the government shutdown. That's fine. Then don't hold the press conference. Just release the data in a public repository so that scientists can use it. But when you hold a press conference, it means that you have something meaningful to say. And there were only officials in that press conference. If you wanted to say something meaningful, you should bring scientists that wrote scientific papers analyzing data from the Webb telescope, the Hubble telescope, and so forth, which was much more interesting actually than the new data that was shared. Anyway, the only takeaway for me was that the image of 3I Atlas taken by the high-rise camera when it was coming within 30 million kilometers from Mars, it was a sideway image, for the first time, we had an image where the direction of the sun is not close to the direction of motion. Because previously we had images of 3I Atlas approaching us. And so the direction of motion was very close to the direction of the sun because it was far away when these images were taken by the Hubble telescope, so forth. But when it came close to Mars, we saw it from the side. The direction of motion was nearly perpendicular to the direction to the sun. And lo and behold, the extension, the elongation of the glow around the 3I Atlas was in the direction of motion, preceding the object. In other words, there was a glow in front of the object in the direction of motion, not aligned with the direction of the sun. And you would expect that if there are pockets of ice being sublimated by sunlight, then the gas and dust that comes out of those pockets would be towards the sun because the sun-facing side is being heated, warmed up by the sunlight, and then they can get pushed away from the sun by the solar radiation pressure and the solar wind. So there is a preference to the axis connecting the object with the sun when you deal with standard cometary evaporation. However, the elongation, the actual how should I say, plume, the plume of glowing plume was in front of the object in the direction of motion, perpendicular to that of the sun. So that's a puzzle. They didn't even mention that. That's one of the anomalies that I listed today. I have 13 of them. So anyway, that's as far as I'm concerned. They should have brought scientists. They should, or they shouldn't have held the conference if there is no substance there, because the public felt offended. You know, the public support science through taxpayers. We should listen to the public. We should respect the public. And most of all, we should show curiosity that drives our research. That's what the public wants. And we should be honest about the fact that as scientists, we don't always know the answer. And sometimes we make mistakes and we take risks. So my fundamental point, I'll summarize it with one sentence, that the foundation of science is the humility to learn. It's not the arrogance of expertise. And what we saw in this press conference is the arrogance of expertise, basically telling the public what they should know from the experts. And that is very common in press conferences. That's the mistake made by most scientists. They lecture to the public. They tell the public the truth. The other mistake made is not to attend to the public's interest. You know, the public supports fundamental science. Then astronomers take this money and define within the decadal survey, 2020 decadal survey of astronomy and astrophysics, define their primary goal, the most important priority, to look for microbes. That's in the decadal survey. $10 billion over the next 2 decades. So they basically tell the public, give us the money, and we decide to allocate more than $10 billion to the search for microbes. The public, based on my interaction with the public, cares much more about the question whether there is extraterrestrial intelligence compared to, I mean, of course, if we find microbes, that would be amazing. We will have, you know, primitive life elsewhere. We can ask if it's the same DNA and so forth. But the public cares about whether we have neighbors. And that receives no support in terms of recommendation for federal funding. So zero doubt on what the public cares about. We know better than the public what we want. We want to go for microbes because it's too risky to go for intelligence. And I say, look, this is the public's money. And by the way, this is the most fascinating question that can change the future of humanity. How dare academia sideline this possible question and not address it head on with the best instrumentation, the best tools that we have, scientific tools, just make it part of the mainstream. And you might say, well, the mainstream doesn't like risks. That's not true. For 50 years in fundamental particle physics, fundamental physics, you know, the torch in front of physics was obsessed for 50 years with extra dimensions in the context of string theory and with supersymmetry that was not found in the Large Hadron Collider after investing $10 billion there. So you can't tell me that the mainstream never takes risks because they worked for 50 years. That's a whole generation. on a completely hypothetical, speculative idea of extra dimensions. But because there was a big enough community, they felt it's completely legitimate. They gave each other awards and encouraged each other. And all of these people who are basically pushing back against what I say, they have no single critical word to say about the fact that for 50 years, a community of thousands of physicists was working in a complete speculation that has no backing from any experiment and does not even foresee an experiment that will test their theory. So they have nothing to say. Why? Because there is a big community there, and they feel that it would be dangerous for them to express some critical remarks about this. It's sort of like a cult. When enough people believe in something or do something, then it's acceptable. But it's not judged by the merit of the idea. And my point is, the public cares about a question that we, as scientists, are ignoring. That's completely inappropriate. That's about the press conference. Now, let me get back to 3I Atlas, because you started from that. 3I Atlas is the third object from outside the solar system that was discovered over the past 8 years. And from now on, we will find many more, because the Rubin Observatory in Chile will discover a new one every few months. So that's what we expect. So there is a fundamental question of what are these objects? Where do they come from? And the premise of comet experts is these are most likely comets. That's because you expect icy rocks from the outskirts of the solar system to be expelled from the solar system as a result of passing stars. And the most common thing you would find in interstellar space are icy rocks from the outskirts of planetary systems. So most likely it's a comet. Fine. I say, let's be humble, okay? Let's look at the evidence and ask, are there any unusual features that may not indicate what you think it is? Because initially the experts said it's a water-rich comet. So anyway, the minute this thing was discovered on July 1st, 2025, this year, I immediately calculated the expected size of the object if the brightness comes from reflection of sunlight. Turns out to be about 20 kilometers. Now, it's true that a lot of the light may be scattered by gas or dust around this object. So that was sort of an upper limit. But then most recently, during the months of July, August, and September, we had a lot of 4,000 data points about its motion in the sky. And we knew that it gets evaporated with a mass loss rate that was measured by the Webb telescope on August 6th of about 150 kilograms per second, mostly from the sun-facing side. So I calculated how much recoil it should get. It turns out that it has to be extremely massive not to show any recoil during those months. And the mass has to be 33 billion tons at the very least. And you take the typical solid density of comets and you find that its size needs to be above 5 kilometers. The diameter is at least 5 kilometers. So this raises an important question. If it's 5 kilometers, it means that it's 1,000 times more massive than the second interstellar object that was found. It was the comet Borisov that looked just like a regular comet. So here we see another object, already 1,000 times more than the previous object, and it's 1,000,000 times more massive than the first object. So we had 3 objects, and this one is 1,000,000 times more massive than the first one. So I would expect, given the limited mass reservoir of rocks in interstellar space, and I did this calculation just a couple of days after the object was discovered, there is no way you can deliver a package that is so big, 5 kilometers or more, over a period of 1 decade, because there is limited mass in rocks in interstellar space. And moreover, you would expect 1,000,000 small ones, like Oumuamua, the first interstellar object, for every big one, 5 kilometers or more, like 3I Atlas. We didn't see 1,000,000 small ones before we saw the third one. So that was the second surprising fact. And then another fact, turns out, so I said maybe it's not drawn from at random from rocks in interstellar space. Maybe it's targeting the inner solar system. Turns out that its trajectory is aligned with the planets to within 5 degrees. Okay, so there is this ecliptic plane of the planets around the sun, and the different planets, by the way, the ecliptic plane is defined based on the Earth, but then the planets are moving up, they are distributed with an inclination of a few degrees around this plane. Okay, so the planets have a scatter of a few degrees inclination. This object comes at 5 degrees, comparable to the scatter of the planets. And moreover, just yesterday, that's the most amazing anomaly. I calculated, there is the JPL Horizons calculator for the orbit of 3i Atlas. It gives the distance of closest approach to Mars on, sorry, to all the planets, but then also to Jupiter on March 16th, 2026. So 3i Atlas will get closest to Jupiter on that date. And it turns out that it forecasts that the distance, the minimum distance from Jupiter would be exactly to 4 digits, exactly the so-called Hill radius of Jupiter, meaning the radius inside of which Jupiter's gravity dominates over the sun's tidal force. So this coincidence has a chance, if you just do the math, of 1 in 26,000. It's 4 significant digits, exactly the value of the Hill radius. By the way, the Hill radius changes over time because Jupiter has some eccentricity around the sun. Changes by much more than the precision of this agreement on March 16th. So on March 16th, I took the distance of Jupiter from the sun. Based on that distance, I calculate the Hill radius, and it turns out that within 4 significant digits, it's exactly equal to within the error that we have right now for its trajectory. And the interesting point is, this was not perfect agreement to start with, unless the object was receiving some non-gravitational acceleration, which it did close to the sun. So the non-gravitational acceleration that 3i Atlas had when it came near perihelion, nearest to the sun, we measured it. The JPL Horizons data set has some non-gravitational acceleration. There was a slight change in its path, and that brings it to the perfect agreement. If you didn't have that, it would miss the Hill radius to 4 significant digits, which is an amazing coincidence. And I just realized that yesterday. And so the question arises, if it's hypothetically a technological mothership that wants to release devices that will stay around Jupiter, then it needs to come within the Hill's radius. But it may want to put them, for example, in the Lagrange points, L1 and L2, which are exactly at the Hill radius. Or it might have already something that was deposited there a while ago, and it comes to collect it or something. I don't know the reason, but the coincidence is just amazing. One part in 26,000. You cannot argue with numbers. You calculate and the Hill radius, once again, changes over time. So we're talking about the time of closest approach. It matches to 4 digits. And that is only after you make corrections for the path of 3i Atlas as a result of its non-gravitational acceleration. Now, what we see, and by the way, with amateur astronomers' telescopes, since it came closest to, we couldn't look at it when it was closest to the sun because the sun was in the way. And that could be also a matter of some design of the trajectory. We couldn't look at it. But after it went away from the sun, now amateur astronomers got beautiful images of it with telescopes that cost only a few $1,000s. We're not talking about $1 billion cameras that NASA invested in. So that's amazing that amateur astronomers gave us so much information in recent weeks. And what we see are jets coming from the object in many directions, not just, towards the sun, away from the sun, and possibly sideways. And we see these jets, and the fundamental question, are these jets just pockets of ice being sublimated by sunlight, or some technological thrusters? And the interesting thing about the jets is they're tightly collimated and are not changing direction. And we know that the object itself is rotating with a 16-hour period. That was measured back in July. And so the question is, if you have an object, a natural object that is spinning, that is rotating, and suppose there are pockets of ice that get sublimated, they will show, I mean, the jet that comes out of them will show some wiggles or gaps. When those pockets of ice are not pointed towards the sun, there will be a gap, and then there would be some wiggles because of the rotation. We don't see that in those jets. A 16-hour period times the typical thermal speed of the gas is tens of thousands of kilometers per second. We don't see wiggles on that scale or gaps. So there is a question of why do the jets maintain their directionality? Why do we see jets away from the sun, not just towards the sun or sideways? And there are 7 of them that I counted in one of the images. So, I think that the beauty of science is that we will figure out the answer by getting better data in the coming weeks. And my biggest question, I was asked about it last night by a reporter. What are you mostly looking for? I'm looking for data, spectroscopic data on the jets. I want to know their speed and their composition, because natural jets that come out of sublimated volatiles have a speed less than about 400 meters per second. Whereas rockets, thrusters produce jets that are, if they're chemical, they're at least a few kilometers per second, a factor of 10 more, higher speed. And then you have ion thrusters that can reach tens of thousands of kilometers per second. So that's another factor of 10. Sorry, tens of kilometers per second. So that's another factor of 10. So altogether, technological objects that we have are using ejection speeds that are 1 to 2 orders of magnitude above that produced in comets. And so we can tell the difference. And obviously, alien technology might use even more powerful thrusters. So if we end up, I have no issue if we end up with the jets being just defined by what we expect from sublimation of ices on the surface of a rock, so be it. But then, why are all these anomalies? And I have 13 of them. I mentioned just a few.
Avi, how unique is it for an object to have these kind of anomalies and these kinds of questions? And why do you think the traditionalists or the mainstream scientists, astronomers, whatever their discipline is, don't hit on them or have questions about them as well?
Right. So many of them just look at the fact that there is some a plume of gas around it. They call it a coma, which we see around comets. And they miss the point that imagine a technological object that goes for billions of years through the cold interstellar medium. It would accumulate on its surface ices from the cold interstellar medium. It would accumulate dust. We just don't know where it came from. And when that gets warmed up by the sun, you would get a plume of gas and dust around any object. So the fact that you see the appearance of gas and dust around an object don't judge a book by its cover. That's my fundamental point. If it comes from the skin of the object, you don't know what's in the interior. Now, how would you tell the difference? Very easily. If you see a source of heat, it may tell you about an engine. If it's much more than the sunlight can warm up the surface of a rock. Or if you see maneuvering, or if you see some unusual light coming from it, artificial light. Or if what I just mentioned, that it goes with a purpose, it goes exactly to the hill radius for some reason, and that we can verify when it gets there. Why is it so precise? I mean, it's just 1 in 26,000, just this anomaly by itself. Now, the experts are just ignoring that. In the press conference, you didn't hear about that. One reason is, I did the calculation about the reservoir of rocks in interstellar space based on very reasonable assumptions. I got that you can get such a big object, maybe once per 10,000 years, coming into the inner solar system. They didn't go do this calculation. They don't do the calculation. They just say, comets are different from each other. This came from another environment. We don't know where it came from. We should allow. So they allow for a huge diversity of properties. And I say, an object that is a million times more massive than the first one is, not supposed to be the third one. That's common sense, and I don't understand why they ignore it. The other thing to realize about experts, comet experts, is, I don't blame them. They behave just like AI systems, artificial intelligence systems, because what they say depends on their training data set. Okay, so an AI system, the ones that we use all the time, they are as good as the training data set. So when you have a comet expert that was trained for decades on a training data set that includes only comets, then that person will always say anything in the sky is a comet. And indeed, that's what happened on January 2nd this year when the Minor Planet Center cataloged a near-Earth object as an asteroid. They said it's a near-Earth asteroid, gave it a name, and then a day later realized that it's the Tesla Roadster car that was launched by SpaceX in 2018. So then they say, oops, we know that this one is technological. We take it out of the catalog. Sorry, it's not a rock, it's a car. And the only reason they knew about it is because we launched it. Now imagine a more accomplished space entrepreneur than Elon Musk on another planet elsewhere, sending a car. I bet you that the Minor Planet Center would insist that it's an asteroid. And maybe if it has properties that are unusual, like for example, Oumuamua, it had exhibited non-gravitational acceleration and didn't show any gas or dust around it for sure, because the Spitzer Space Telescope looked very deeply, didn't find carbon-based molecules there. And then what did the experts say? They call it now, actually over the most recently, they call it a dark comet. What does it mean, a dark comet? It means a comet that doesn't show the characteristics of a comet, which is a cometary tail of gas and dust. So I say that is an oxymoron. I mean, I'm saying we can solve this problem of them not making sense by simply allowing their training data set to include technological gadgets of the type that we launched to space. They just need to add that into their vocabulary, which they don't. So if you take all these experts and add to their vocabulary space objects that are technological in origin, I bet you that they would be much more open-minded. Because if we launched over the past 50 years so many objects to space, what is the reason for us to assume that other civilizations more accomplished than us, that may have operated for billions of years before we came to exist, did not do that? How come we're so arrogant or limited in our mindset to imagine that it's only rocks in the sky?
Sure, you wanted to say something.
Uh, my question is, I note that all the planets except for Mercury and Jupiter all have rather inclined axis, and I kind of go, particularly those that are the dwarf planets out way out there. They also have inclinations that are outside the ecliptic plane.
Right, by a few
Do
degrees.
you think that that's basically been caused by interstellar objects, or do you think it's more likely that it was done by planetesimals that just bang into each other?
Yeah, I think it's the latter, most likely. The planetesimals during the formation of the planets, but also dynamical interactions among the planets. For example, Jupiter is known to affect many other planets. And I should say, there were many more planets in the solar system that were ejected because their orbits were unstable over a time scale of billions of years. And we just don't know that they existed. There may have been even, an Earth mass planet that was lost and was frozen, and so there should be, in interstellar space, you should have planets that were kicked out, but dynamically by gravitational interactions from planetary systems. It's difficult for us to detect them because they're very faint, but we can see them, for example, when they pass in front of a background star, they can introduce gravitational lensing. That's an effect due to general relativity, where the light bends from the background star, bends around the object, the lens, and you get multiple images or brightening of the background
Mhm.
star. And there are detections of rogue planets, claimed detections of rogue planets, mostly Jupiter size or more massive, in interstellar space. And presumably there are many Earth mass planets out there. And you can even imagine that they might sustain life if the surface layer gets, if you have an Earth mass planet and the surface gets frozen, under the surface, let's say at a depth of more than 50 kilometers, you could still get liquid water because there
Mhm.
is radioactive energy input. It's not coming from a star, but it comes from radioactivity. And I did a calculation, I have a paper on that. So objects that are the size of the Earth can have life forms in them, even if they are ejected and do not have a star next to them. And in
Mhm.
fact, this may be the most common form of life in the Milky Way that it will be very difficult for us to find. But if you ask where are most of the microbes, it may well be in a large population of Earth mass planets that were kicked out of planetary systems.
Mhm.
But in order for us to find the life there, we need to leave the solar system and go there and drill through the ice. I mean, we can already try to check if Europa, that has an ice shell, and has a liquid ocean under
Mhm.
the ice, has life in that ocean. That's one of the future missions that NASA plans to do.
Uh,
Peter, you
I
wanted
was
to say
I
something?
was hoping to get back to how many interstellar objects do you think comes through the solar system
Yeah. So
per year?
yeah.
And therefore, if we're looking for them and we got the right instruments, of course, how many can we possibly see in a year?
Right. So that depends on the size of the object that your telescope is sensitive to. And because we detect them by reflection of sunlight. Just to give you a sense, the survey telescopes that we use right now, like the Rubin Observatory or the Pan-STARRS Observatory, they can detect an object the size of a football field within the Earth-Sun separation. Okay? And such an object appears once a year, roughly speaking, within the Earth-Sun separation. But we don't always see it because, for example, the Rubin Observatory is only covering the southern sky. We need a copy of the Rubin Observatory to see the northern sky, so you lose a factor of two already. And then it needs, this object needs to uh, appear for long enough time for you to notice its speed and so forth. There are all kinds of observational requirements, so we are missing some. But uh, roughly speaking, such an object the size of a football field should arrive within the orbit of the Earth around the Sun once per year, and that's based on Oumuamua in particular. Now, 3I Atlas, as I said, is surprising because it's so massive. We didn't expect it. Objects like it, we would think that come within, once per decade within the orbital radius of Jupiter or so. That would be roughly my estimate. But still, it's very surprising because it's a million times more massive than Oumuamua was, the first interstellar object. So, we have small number statistics, but that's just to give you the sense. Now, if you go to smaller objects, I actually, with my student Amir Siraj, we discovered an object that appeared as a meteor that was roughly half a meter in size, collided with Earth, and was moving before that at a very high speed, actually similar to that of 3I Atlas outside the solar system. So 60 kilometers per second. So we announced the discovery of an interstellar meteor that was actually identified in data of the US government satellites in 2014. And I led an expedition to retrieve materials from this object in the Pacific Ocean, and it will be featured in a Netflix documentary that will come out next year. But at any event, if you do the calculation for objects of order half a meter to a meter, they are much more numerous We see them only when the Earth collides with them, and the cross-sectional area of the Earth is quite small. But there should be a lot of them, about 1 million of them, within the orbit of the Earth around the Sun right now. 1 million rock. I mean, as long. By the way, all the numbers I mentioned is for objects on random trajectories. Okay, so no technological aspect to them, because technology can bring objects preferentially to our inner solar system, even if their abundance is very small. They just choose to come here. But the other thing to keep in mind is if you have one object, let's say the size of a football field, within the orbit of the Earth around the Sun, at the same time, there are a quadrillion objects within the solar system out to the edge of the Oort cloud, 100,000 times the Earth-Sun separation. So for every object you find within the orbit of the Earth around the Sun, there are 10 to the power 15, huge number of objects on random trajectories within the Oort cloud. So just think about it. What it means is, it means that if you talk about random objects, objects that are natural in origin, you need to produce of order a quadrillion of them by every star in the Milky Way galaxy, because the Oort cloud of the Sun is touching the Oort cloud of the nearest star. So you can think of those Oort clouds as densely packed billiard balls. Okay, and so every star should have released on average 10 to the power 15 objects if you see one of them within the orbit of the Earth around the Sun. And that's the challenge you need to account for. You need to explain in the context of a natural origin for these rocks. And so that's why it's so challenging to explain an object that is 1 million times more massive than an object that is the size of a football field. That requires a lot of mass to be ejected from planetary systems, much more than is reasonable. And that was my point. And of course, the NASA press conference didn't even mention that.
Peter, you wanted to say something?
Sure. I'll be brief. Dr. Loeb, Avi, as a non-engineer, I find your focus on intellectual discipline very pleasing, and you make a very compelling case for more and better analysis. Unless you've already said it, what do you think was NASA's motivation to present the information in such a limited way? Was this carelessness? Was this lack of skill? Or do you think there was an alternative agenda?
No, I don't see any hidden agenda. I just think that it's the fault of bureaucrats not to be visionary. That's usually the case in any bureaucracy. Administrators do not have the passion, they don't have the vision, they don't have the excitement of scientists. It's just like managers of soccer teams. They're not necessarily as interesting as the players. And so the mistake here is, and of course NASA doesn't have a permanent administrator. I mean, on December 3rd, Jared Isaacman will be arguing for the position in the Senate. But that may be part of the problem, that for many months they were not really led by an administrator. And so they decided, given the shutdown, and of course that hit them hard as well, they made poor decisions. Like the decision to hold a press conference without a clear, exciting message, that harms the reputation more than not holding it at all and just giving the data to scientists. That would be my choice. Or if they were to make some press conference, they should bring scientists that would explain how the Hubble image and the Webb telescope spectrum of 3I Atlas was so amazing, which one can make the case for. I mean, I completely agree with that. And there was also the Sphere X data. So there was data of great excitement that came out from NASA's instruments, except it was released before the shutdown. So to come back to a press conference after the shutdown with no new information in addition to that, and just say we have a lot of instruments that looked at. I mean, this is just a poor bureaucratic judgment. And so I don't blame, that's their job. They're bureaucrats, they're officials. But I think the public is excited by science that is willing to explore the unknown, is willing to learn something new. And if you don't learn something new, don't speak about it. Okay, if it's not fascinating in your mind, why should you just make a public appearance and say it's not interesting? Like this is not serving any good purpose.
Thank you, Toda.
Is it plausible to expect an outcome that in a reasonable amount of time says it's natural or artificial?
Yeah, I think within a month, it will come closest to the Earth on December 19th. Just around the time of the holidays. My wish is that it will not deliver any unwanted gifts for the holidays to Earth. But by then, there would be hundreds of telescopes looking at it because there is a campaign that is being organized by the International Asteroid Warning Network. It was announced a few weeks ago, and they will basically coordinate observations from hundreds of as many observatories as they can get coordinated between November 27th, a week from now, and January 27th. So that would be amazing. And the beauty of science is that if we can get data, we should get data and then decide, how unusual is the object based on the data. But if we say in advance, oh, it's just a comet, it's a comet that came from another environment, then you decide maybe not to take data as much as you could have, and you miss opportunities to learn something new. And that's what happened with Oumuamua. At the time, it was called a comet, and then the category changed to an asteroid, and then a comet again, now a dark comet. And during the time that we could observe it, we didn't take advantage of our best observatories. And just to give you an example, one of the anomalies that I identified was the coincidence of the WOW signal from 1977 being within 9 degrees of the arrival direction of 3I Atlas. And I encourage radio observatories to look for radio transmission. So a few days ago, there was the first report on a limit on any radio transmission during one day, November 5th. And that was obtained by the Meerkat Radio Observatory in South Africa. And they basically set a limit on transmission at frequencies between 0.9 and 1.6 gigahertz at the level of a cell phone, the power of a cell phone. We don't know. I mean, there could be transmission at different frequencies on different dates, but at least it's a meaningful limit. And when the NASA officials said, we don't have any evidence for technological signatures, these are not the kind of signatures that, strike you in the face. You have to search for them. So it's a self-fulfilling prophecy to say, I don't see anything unusual if you're not looking, And so when we look, for example, in the radio, we can put meaningful limits on any transmission. So with a Webb telescope, we can look for any heat, excessive heat coming from an engine. We could measure the speed of the jets, all kinds of things that will tell us a lot about the nature of the object. So I think within a month, my hope is I will be able to update the ranking of the object. I developed a scale where 0 is a natural object and 10 is a technological object. It's called the Loeb scale in a couple of papers that we wrote. And I will be able to be more assertive as to the actual ranking. Maybe it will be close to 0 if we see that all the properties are consistent with a natural comet, or because of the anomalies, it will be closer to 10. So we shall see.
Some of the
I want to ask a question
for you.
Yeah, go
Hello?
ahead.
Yeah. Does it look like this object will, though, leave the solar system after the pass-bys?
Yes.
That's
Yes, the non-gravitational acceleration is really small. It's about 1 part in 1,000 relative to gravity near the sun. It was really small. So it looks as if it follows, by and large, the original path, except with a small correction, which was by now detected with high significance. But the fundamental question, so it will not be headed towards the Earth. In fact, it was avoiding the Earth. It came closest to the sun when the Earth was on the other side. If the Earth was 6 months earlier, near the when the object came closest to the sun, the 3I Atlas would have been within 50 million kilometers from Earth, which is amazing because that's similar to the distance it gets close to Jupiter or Mars. And if that were the case, we could have used radar. I calculated radar systems transmit radio waves and get them and bounce them off an object. They can map the surface if the object is close enough, and we have those facilities. And if we were 6 months earlier on the other side of our orbit around the sun, then we could have imaged 3I Atlas in 3 dimensions. Because as it spins every 16 hours, we would take snapshots of it and get a full image of it. But unfortunately, we are here, and the closest it will get is within 1.8 times the Earth-Sun separation, so 250 million kilometers or so. So that's, that is not very close, but it's the best we have. So we should make the best out of it.
Avi, I have a question for you.
Okay.
Regarding the anomaly of the anti-tail, the gas jet pointing towards the sun as opposed to away, like most comets do. I think you said that is unusual, but in reality, comets have done that before. In fact, Comet Kohoutek did that back in the early 70s. So could you speak to that anomaly? And also, if this object is an alien spaceship that's got thrusters, and it would appear that they're not trying to hide themselves, and maybe that's an indication that it's automated. That would be exciting as well. But I just wanted to get your thoughts on, wow, they're not trying to hide themselves at all.
Well, from the calculation I did yesterday, that indicates that it comes at a very special distance from Jupiter on March 16, 2026. To me, it suggests that we don't count. It's not about us. We always think that it's about us. We thought that we are the center of the universe, and the human species existed only for a few million years on Earth. Jupiter existed for 4.5 billion years. And it's the biggest planet. And if they started their journey a billion years ago, they didn't have us in mind. Okay, so they sent it for some other purpose. And so we shouldn't think that it's about us. And my sense is that it's more about Jupiter based on the coincidence that I mentioned. Now, with respect to the jets, you are entirely correct that the sun-facing side always is the most likely side to have the evaporation of ices from the surface of a nucleus. That's obviously the case because once the object rotates and you go to the night side of the object, it's very cold there. The temperature variation can be hundreds of degrees between the day side of the nucleus and the night side. And so as soon as the object, within less than hours, the surface cools and freezes as soon as it's not facing the sun. So you would expect evaporation mostly in the direction of the sun. That's definitely the case. And very often that evaporation will be in the form of jets. And they should shut down when they go to the night side. But what is surprising is not that. I mean, what happens usually is that you see evaporation towards the sun, and then the gas and dust that comes out of the nucleus gets pushed away from the sun by the solar radiation pressure and the solar wind. Now, this is simply because the dust particles have a characteristic size. Most of them have a characteristic size comparable to the wavelength of sunlight, which is a fraction of a micron, half a micron, micrometer. And so they scatter sunlight effectively. These are the most efficient scatterers. And they have the largest amount of surface altogether for a reasonable distribution of dust particles. So they are dominating the scattered light, those micrometer-sized particles. But those are also the particles that you can easily show, and I did the calculation, you can show that they immediately get pushed. On a very short time scale, of days, they start trailing the object, because for the same reason that they scatter sunlight, they also get pushed by sunlight to trail the, if the object is approaching the sun, to face the opposite side, okay, relative to the object. So the surprise here is not the fact that the dust particles start facing the sun, and it's the fact that there is no turnaround. So if you look at the Hubble image, what you see is that behind the object, there is no extension. Okay, the object looks spherical, more or less, or I should say the coma looks spherical, starting from the sides and going to the back. So there is no difference between the extension backwards away from the sun and the extension sideways. Both have the same
So
radius. And then
sorry, Avi.
yeah.
This phenomenon has been seen before in other comets. This anti-tail towards the sun.
No, so what was
So
seen before, very often is an optical illusion, or just because of the geometry where the Earth is relative to the comet. Sometimes, the fact that there is a tail being pushed away from the sun is, when you look at it from the wrong angle, it looks as if it's ahead of the object. It's not seen, it's not common. This is definitely not common. What is common is this optical illusion when you look at it from the wrong angle. But just because of the physics that I mentioned, it's always the case when you have micrometer. It's not a question of seeing, it's just a question of physics. If you have scattering of sunlight by dust particles that have submicron size, you can calculate the force from the sunlight, and the force would bring the particles away from the sun. It will never push them towards the sun. There is no way it can do that. So there is no doubt that this physics operates and you can't avoid it. The question is, what is going on with 3I Atlas? And one possibility is that, you have dust particles that are at least 1 million times more massive than typically we see. So, there are 100 microns or bigger. And in that case, the amount of surface they have on which the sunlight acts is much less per unit mass. So, the mass of an object goes like radius cubed, the mass of a particle, and the surface area goes like radius squared. So when you make the particle more massive, then you basically create less surface per unit mass. And if in that case, there would be less force acting on those. So you can get a situation where very large dust particles, 100 times bigger or 1 million times more massive than typically, would maintain their inertia and continue forward without being pushed back. That's one possible explanation. Another one that we wrote 2 papers about with my colleague is that you basically break fragments of ice from the surface, and then the ice gets evaporated, sublimated by sunlight, and it doesn't have time to turn around and appear away from the sun. So that's the other explanation. You see, I'm thinking about situations like that from a basic physics point of view. Okay, so I don't care if the animal has some features on its skin in this way or that way. It's not about phenomenology. It's a question is, what is the physics responsible for what we are seeing? That's the way I think about it. And the way comet experts think about it is, okay, just like in baseball games, what is the statistics? Like how many times did the pitcher throw the ball this way, and is it common or not? That's not a good way to think about things. The question is, if you see the pitcher throwing the ball at a 10 times faster speed, how did that happen? There must be some physics behind it, okay? And if you understand that, then you can explain what is special about this pitcher. So that's what I'm trying to understand about 3I Atlas. And just, what I often hear from comet experts, comets are very different from each other. We can't generalize. They just escape from thinking about the physics, which is not a good practice, in my opinion.
But
You began your remarks by commenting that the government should be investing more in trying to find interstellar objects and interstellar intelligence specifically. But I note that you're part of a group of scientists, the Galileo project, that's trying to do that effort independently. Can you give us a brief update on how that's going?
Yeah, so I'm the head of the Galileo project, which was established after the Director of National Intelligence delivered the reports to the US Congress saying that there are objects they don't understand. And that is a serious matter because they are basically admitting that they are not doing their job. The US government puts $1 trillion in the defense budget of 2026. And, it's really embarrassing if after looking at the sky, there are things, that we don't understand. And because it could come from adversarial nations, that would be the easiest explanation. And that means they have capabilities that we are not addressing. And the example of the Chinese spy balloon was one in which it took a while and eventually it was shut down. So, the unusual thing about the reports from the Director of National Intelligence was that they're admitting that they're not doing their job. Now, obviously, any employee of government would prefer to classify as much information as possible so that nobody would know that they're not doing their job. But in this case, they were forced, I guess. That's the problem with government bureaucracy, that very often, because it's not exposed to critics or the public, you don't know how incompetent the work is because it's hidden from view. And especially if you can classify what you're doing, that's a perfect recipe for not getting criticism. But when you deal with the national security, that should not be tolerated. So at any event, my point is that it's a serious matter. And of course, if it happens to be some of these objects happen to be technological devices from extraterrestrials, that would be even more exciting because it will be the biggest discovery that humanity ever made. So that's the rationale for the Galileo project. We're basically saying, if it's anything to do with technologies beyond Earth, we don't need the government to tell us what lies outside the solar system. We can, if these objects are out there, let's see if we can find them. And we built 3 observatories, the latest one in Las Vegas. I mentioned it in the interview I had with Joe Rogan just a few weeks ago. We are attempting to triangulate objects in the sky, in other words, looking at them from different directions so we can pinpoint their distance, velocity, acceleration, and ask with machine learning software whether there are any outliers that have characteristics beyond the performance envelope of human-made technologies. So that's the rationale, and I would be happy no matter what, because even if it turns out that all the objects are human-made, I'm happy to give everything we learned, the type of sensors we developed, the software we developed, the machine learning software, to give it to the Pentagon so they can use it. Or whatever we learned, they can take advantage of that would benefit the security of the nation. So as a citizen of the United States, I'm very proud to potentially help them. But if it turns out that any object is beyond the performance envelopes of human-made technologies, that for me as a scientist would be quite remarkable. And we just have to wait. So we are planning to monitor a few million objects in the coming year, and we'll see what the data shows.
I know we're coming up on the end of our hour, but what are these sideways lines or striations we see in some of the pictures? And are those normal on comets, or is that an abnormality? What can you say about that? They look strange.
Right. Yeah, thank you. So I actually wrote an essay about that a few days ago. But the one caveat to keep in mind is there are satellites, all these communication satellites that Starlink and other companies put up there. And I did a simple calculation, and actually in any frame, in any field of view that is of order 20 arc minutes, which is the typical field of view of those images, you would expect a few satellites to cross that field of view during a period of order, 10 minutes to an hour, which is a typical exposure time when you combine. What they're doing is stacking images from many exposures. Now, the time it takes a satellite to cross that field of view is only a few seconds. But when you stack images, one of them should have the satellite because it's only a few seconds, and the typical exposure time is, tens of seconds. So it's easy to tell if it's a satellite, a human-made satellite around the Earth, because it would appear only in one of those images being stacked. But when they give us those final images, usually it's the cumulative the addition of all these snapshots that they took in order to get the higher sensitivity. And there we see these lines. And that's what worries me about these sideways lines. They could be just satellites. There was one image where the line crossed exactly through the nucleus of 3I Atlas. And I wrote an essay basically saying it's most likely a satellite, but if it's not, then it's extremely puzzling to see jets coming, being so narrowly focused. And maybe, that's a technological signature of 3I Atlas. But it's very easy to tell if it's actually contamination by human-made satellites. Just, the photographer just needs to examine the different images in the stack and see if only one of them shows it. And moreover, later on, if another photograph is taken an hour later, 2 hours later, it shouldn't show the same lines. So it's unfortunate that communication satellites are really introducing lights in the sky. And we, traditionally in astronomy, we try to avoid city lights. And now Elon Musk is putting lights in the sky for us. And it degrades our ability to look at the sky. But we can cope with that. And also there are some catalogs of satellites that, these are not all the satellites, because there are many of them that are used for national security, for espionage, and those are not public. And by the way, the Rubin Observatory, when it looks at the sky, the director of the science team there said that a representative from the US government asked him to pass the data through a filter, which doesn't take a long time, but this filter basically looks for all the classified satellites in the data, takes them out so that the astronomers will not be aware of them. And that's what Zelko said, the director of the science team. So there is definitely contamination by those satellites, and we need to avoid them. But it's easy to do that with the 3I Atlas. So far, we do see jets, but I wasn't convinced about the one case where there was this line passing through the nucleus.
When you were in Vegas, did you place a bet on it being technical or natural?
No, I was busy. We started 4 a.m. because it gets very hot during the day there. And I didn't sleep much that night, actually. And frankly, when I arrived at the hotel, I really hate to see people losing money. They get addicted. It's really it's not good for themselves. And it's really sad to see. It's like people on heroin or drugs, that they just, obviously the house statistically wins, but it's just sad to see people with great hopes that are losing their vitality. Instead of doing something constructive, they just bet their money. And that is, I really, whenever I go through a casino, I get depressed.
But natural or technical, what say you?
Oh, if I had to bet. Yeah, so right now my inclination is towards the natural, but this is just a guess. I think we will know much more in the coming months. And then I can tell you for sure what I think.
Does the mainstream publish all of the data? Because, there's conspiracy for everything under the sun, but they say that data is withheld. Do you see data being withheld, or that's
No. I think what you can expect, based on the people I know that are either at NASA or in science, is not that they purposely withhold data. It's just that they have a prejudice. They think it's something. So either they don't observe to look for, to test their assumptions. They do not even take the data in the way that it should be taken, like looking for things that behave differently than what you expect. Or they interpret the data. So let me just give you an example. There was much more nickel than iron found around in the gas plume around 3I Atlas. And that is extremely unusual, never seen before in any comet. Usually you see nickel and iron with similar quantities. In fact, the solar composition has more iron than nickel. However, in this one, in fact, the first observation was just nickel and an upper limit on iron, at least more than 10 times smaller. So the only place where we see that is in the industrial production of nickel alloys. It's called the carbonyl pathway, chemical pathway to making nickel alloys. Everyone that works in the industry of making nickel alloys knows about the carbonyl pathway. So what did the authors of that paper say? They didn't say, wow, this is unusual because usually we see it in the industrial production of nickel alloys, and this is the first time we see it in nature. No, they said, probably nature is using the carbonyl pathway to create more nickel than iron on the surface of this comet, which came from another environment. That's the way they phrased it. That's where you can find the cheat. The cheat is coming in the sense of there is nothing new because we shoved it under the carpet of traditional thinking. So yes, there is only nickel and no iron. Yeah, the same process that we are familiar with industrial production may be operated in nature. There is nothing alarming about that. That's the way they. Or if you see an object with non-gravitational acceleration like Oumuamua, no gas or dust, you just say, it's a dark comet, meaning it's a comet. Don't worry about it. It's dark. You can't see the cometary tail. So, I feel very often like the kid in Hans Christian Andersen's tale who says the emperor has no clothes. Oumuamua has no tail. And the adults in the room are telling me, yeah, of course it has tail. It's just invisible. It's exactly the same psychology as that. So that's where you should expect the cheating to be in the context of scientists, where they have an idea in their head and they will twist all the facts so that they fit the idea, even if they have to use something that is only used in our industries, or even if they don't see the signature of a comet, they would still call it a dark comet. These are the kinds of cheats. But they will not withhold the data intentionally, as far as I can tell.
Do you have any concluding comments on Atlas for us? I know we promised an hour and we're at that point. Or does anyone have a quick question for you?
My concluding comment would be to say that the best is yet to come because it will come closest to Earth on December 19th. And science should be based on evidence, and let's hope the data will be collected and shared publicly. There is no government shutdown now. And then let's hope the Hubble, the Webb telescopes will look at it. And then we can all judge. When the holidays come, we can look at this data and say, yeah, it looks natural to us. Or it looks really strange, and let's just wait for that data. That's all I'm asking. I'm not making a judgment. I'm just saying we should be open-minded, and that already attracts so much attention, But for example, I had last week, every day I had somewhere between 4 and 8, one day it was 10 interviews. And on Friday, just a couple of days ago, I had a request from former Speaker of the House, Newt Gingrich, for a podcast with him. When we started, he said, look, I really appreciate what you've done. You promoted the appreciation of space much more than anyone else just in recent months. Space exploration. He was grateful for that. And that's a side benefit because I get the public very interested in the subject, and I get a lot of messages from parents, like a mother that says, my son wants a telescope for the holidays as a gift, and a father who said, because of you, my daughter wants to become a scientist. I get a lot of these messages, and just the fact that kids want to become scientists now as a result of listening to me on television, podcasts, seeing, to me is the biggest reward. So even if this blind date that we have with an interstellar object ends up being with a rock, I think it was really important for me to speak out because there would be more scientists, and science may not be conceived by the public as an occupation of the elite. Because I'm definitely not a representative of the elite. I grew up on a farm. I think in simple terms. I really like to think the way the public does. And I don't pretend to be elevated on a pedestal.
Well, I'm glad you're doing what you're doing. I think science and space and getting people excited to explore is what the space show was all about when I formed it 25 years ago. Does anybody have a quick question or comment for him before we let him go and thank him very much for the for the hour or so.
Yeah,
Can
thank
we
you for the
expect
excellent comments. Yeah, go ahead.
when can we expect your Netflix special?
Oh, it should be within half a year or so. It should be fun because just last month, after a day after I was on the Joe Rogan Experience, I went to Bakersfield, California, where there was a NASCAR car race. One of the racers decided to put my image along with 3i Atlas on the hood of his car, and they came with me. So that would appear, I think it will appear in the documentary as well. The racer put me inside the car and taught me how to drive it, and and he invited me to Daytona. They want me to compete there, but my wife does not allow me to take the risk. And the one thing I learned from this race, I should say, is that I wondered when I looked at the race, I said, why isn't it that some corporation designed a self-driving car? We have self-driving cars right now. Obviously, we can design a car that will be, handled by AI, and will do much better than any of the racers in NASCAR. I mean, I'm sure that there could be a self-driving car that beats all these racers because it will optimize the fuel use and the speed and everything. And I then realized
Those
that
are those
what?
are fighting words, I'm sure. So
No, I have a good answer, which is that we enjoy in sports, for example, we enjoy seeing humans challenged to the limit. And it doesn't matter that there is a machine that can do better. For example, there must be robots that can do better than some athletes, but we don't care about that. We want to see humans. The same is true about chess. There are obviously computers are better than humans in chess right now, but we still enjoy seeing chess games. And I argue the same should be true about art, because art is a means of communication among humans. And so the machine will never replace that. You will never pay a large sum of money just for an AI produced picture as much as you would pay for a Picasso, or just because you enjoy the fact that a human made it. The problem is, of course, deep fakes, and that will be a big challenge in the future. But at any event, I'm not that pessimistic about our future with AI. I think there is a lot of room for humans to contribute meaningfully. And I had a podcast with a young girl from Taiwan this morning, and she asked me for advice to the young generation. And my advice, well, first of all, not to rely on AI, but to read primary sources of information. But the second one was not to have AI friends as a substitute to humans, and keep the human connection. It's really important for the health of your brain, and the brain is just like a muscle. If you don't use it, you lose it, and therefore I'm worried that the young generation will become dumber if they rely on AI.
Avi, real quickly, I know you consulted with the producers of the documentary coming out, Disclosure. So,
Yes.
is there anything that is in there that might confirm one way or another that we are not alone or we are alone? What do you have to say about it that you can share with
Yeah.
us?
So it's not so much the producers, but I spoke with some of the key participants in the documentary, and they provided me with information, some of which was not included. But I don't rely on stories that people tell me. I want to see the evidence, and I haven't seen the evidence. So it may well be the case, and I believe that these people are sincere, that the government has materials, biologics related to crash sites of non-human entities, but I haven't seen that. So I really hope that if that's the case, that the government will get back to their senses. And, for example, data from 50 years ago has no national security implications. There is no way that Russia or China or any other adversarial nation developed technologies 50 years ago that we don't know about now, or that are of concern right now. So if there was any incident any data collected 50 years ago, it should be released to scientists if it's puzzling, if it looks as if it's not human. Okay? And because science thrives when the information is being shared. You can't give it to corporations, which do not necessarily employ the best scientists. I would love to help government figure out things that they don't understand, as long as it has not, as long as it's a question of science. That's my day job, to figure out what lies outside the solar system. But I haven't witnessed any of those materials or data that is being mentioned, and I would love to see it if it exists.
So would I. But
You'd have to sign a non-disclosure agreement if you're going to get to see them for the moment.
I don't. Okay, so here is my point. If you ever see me not saying anything about it and saying I can't speak, then you know that I signed something. But in that case, I would really want to know it more than for me, I really want to know what is going on, okay? And I don't mind if I can speak about it or not speak about it. It's not about me, mentioning it to everyone. It's about knowing what is out there. And that I asked the students in my class, I asked them if a spacecraft landed at Harvard Square and they invited you for a one-way trip, would you go on it? And amazingly, all these students said, we would go on it only if there is good Wi-Fi connection so that we can share the experience over Instagram with our friends or something like that. And I said, I don't understand how you think, because who cares about whether if you are going on a one-way trip, who cares about your friends anymore? It's all about the experience and the knowledge that you gained. So for me, signing an NDA would be a similar thing. It's just like going on a one-way trip. I just want to know. And I would definitely go on a spacecraft that lands at Harvard Square, believe me, even without Instagram.
If I may ask, since you mentioned that you grew up on a farm,
Yeah.
can you? This might be a personal question. Can you tell me where the country or something like that? Because I also grew up on a farm, and I got excited about space growing up on a farm for some thing that I didn't need to say in details. But can you tell us where you grew up on the farm and how did that
It's in my book, Extraterrestrial. And I grew up on a farm in Israel, in a moshav, in a small village about 20 kilometers away from Tel Aviv.
Okay.
And we had the chicken, and I used to collect eggs every afternoon. And I would drive a tractor to the hills of the village every weekend and read philosophy books. That was the most interesting thing for me. But we had also pecan nuts and oranges, grapefruits. My father was a farmer, and I always had that as plan B if I don't get tenure at Harvard, for example. But they gave me tenure within 3 years after my arrival, which was the first one in about 15 years from within. So I said, okay, in that case, I'll stay. But I was never worried because I could go back to the farm, and maybe I would have had a more enjoyable life there, embedded in nature. I jog every morning at sunrise in the company of nature, and I can say that I like it much more than reading comments from colleagues. Yeah.
I don't blame you for that.
Sorry?
I said I don't blame you for that. You probably had very clear skies when you grew up
Oh, yeah.
So were you stargazing? Did they have observatories?
No, I was not interested in astrophysics at all. And the only reason I'm doing it right now is because I was offered a postdoctoral fellowship at the Institute for Advanced Study at Princeton. That resulted from the fact that while during my military service, I led a project that was funded by the Strategic Defense Initiative of President Reagan, Star Wars. And that was the first international project funded by Star Wars. And it brought me to Washington, D.C. And in one of the trips, I also visited Princeton. That was about the time when I finished my PhD at age 24. And They offered me a position there under one condition, that I'll switch to astrophysics. I didn't know anything, and I said, okay, I'll do that because that sounded like a good opportunity. And that's why I'm in astrophysics. But I'm very different than my colleagues because I think about the big picture usually. Um, so the way I think about it in science, you can have, I mean, most people are just putting one brick on top of the other. They are just like builders. And when you have a construction project, you're building a building, some construction. Um, you need also an architect, because otherwise you put the bricks and you get something really crazy. It doesn't look right. So you need some blueprint of an architect, and I'm trying to play that role, to tell the community, look, you need to search for intelligence, not just microbes. And they don't listen. They keep putting their bricks on top of each other in a different direction. But this is my strength. My strength is thinking about the big picture, also having ideas that, young people come to me and I ask them, what do you do? And they tell me, and within a few seconds, I ask them a question and they say, oh, I didn't think about that. And then they spend, their career addressing the questions that I asked them. That happened to me many times with students or postdocs. And it comes to me quite naturally. It's just that I think differently. That's all.
Well, I'm glad you do. So
Yes.
thank you very much for being back with us. Happy Thanksgiving and holidays to you and your family, and hope we can talk to you again when you have that evidence. So
Well,
look
thanks for
forward to it.
inviting me. It was a real pleasure. Your questions were excellent, and happy Thanksgiving.
Thank you very much.
Thank you.
Um, Listeners, just let me announce we're in our fundraising campaign. So if you like what we do, please support us, and you'll be seeing information on that. But there are things on the website, and we come back on December 3rd or 4th after a Thanksgiving break up in Sonoma, California. So once again, everybody have a great holiday. Stay safe, keep looking up, and keep an open mind. Goodbye from Avi and the Space Show team.